Welcome to another topic in our chemistry lecture series. In today's topic, we will be looking at writing formulae. Now, the objective that we will cover will include to write formulae to represent ions, molecules, and formula units. Let us begin. Now, a chemical formula is a symbolic representation of a chemical compound. You are expected to know the names and symbol of some simple ions and be able to work out the formula of ionic compounds. Now here we have some names of some simple common ions. The positive ions here are called cations and the negatively charged ions are called anions. Now the formula of an ionic compound represents the simplest whole number ratio of ions present. Bear this in mind, it is very important. Also, the net charge on the ionic compound is 0. That is, the number of positive charges is equal to the number of negative charges, which gives you a cancellation of the charges and is equal to 0. Let's look at some basic things that you should know in order to write formulas. A subscript number written to the right of an element tells us how many of the ions are present in the formula. In this example, we have magnesium chloride. So here we see where we have 1 magnesium and 2 chloride ions present. So normally, when the number is 1, you do not see it. It is ignored. So for example, Mg, the 1 would not be shown, but the Cl that carries 2 will be shown. So any number that is greater than 1 will be shown, but 1 you will not see. So as you see here in sodium chloride, the Na, which is 1 atom or 1 ion of sodium, and Cl, which is also another 1 ion of chloride, you do not see these ions, and so you simply see NaCl. But in the case of, let's say, suppose it was Na and oxygen, then you would need to see Na2 and O would be 1. You would not see a number for 1 there. So it is saying that you have 2 ions of sodium combining with 1 ion of oxygen, which is the oxide ion. So ions in which contains more than 1 atom, in which the group of atoms acquires an overall charge, is called a polyatomic ion. Now another word that is used for polyatomic ion is radical. Now your radical is simply your group of atoms that is governed by an overall charge. For example, oxygen and hydrogen, these are 2 different elements governed by a single minus charge. SO4 governed by a single 2 minus charge. NH4 governed by a single plus charge. So you'll notice that my elements are capital. So it means that this is 1 element and this is a different element. And they're both governed by a single overall charge. Let's write some formulas for ionic compounds. In order to write some formulas for different ionic compounds, let's follow these simple steps. We are first going to write the symbol, after which we will put on the charges. We will then move the charges across to the other ion or the other atom. So here I have -1. I'll move -1 across to Mg, and the 2 plus on Mg, I'll move it across to the subscript of Cl. I will then ignore the charges. And then remember that if 1 is there for an atom, you would ignore that 1. But if the number is greater than 1, you would write back that number. And so the final formula for magnesium chloride would be MgCl2. 1 magnesium to 2 Cl ions. Now, remember again that earlier we said that the compound must be electrically neutral. That means that the number of ions on Mg must equal the number of ions on Cl. And since I have 1 Mg with a 2 plus charge and 2 Cl ions, each carrying a negative charge, I have plus and plus, which cancels minus and minus. Therefore, my charge is 0. And it simply means that this compound now is electrically neutral. Let's try writing a few on our own. Let us write the formula for a few ionic compounds. Let us start with sodium carbonate. We will also do aluminum sulfate. And let's try ammonium nitrate. Okay, so let's start by writing the ion Na+. So sodium is in group 1, so it comes with a plus charge. Carbonate is a polyatomic ion, CO3, 2-. So we'll bring the 2 there, we'll bring the 1 there. So we'll write Na2CO3, but because this number is 1, we will not bracket and put 1. We will leave it as is. And so our formula will be Na2CO3. Now to check to see if it is electrically neutral, I must have 2 sodium ions combining with 1 carbonate ion. So here you see 2 plus combines with 2 minus, which gives you a 0 charge. And so this compound is electrically neutral. Let's try aluminum sulfate. That is Al, aluminum, which is in group 3, and sulfate, which is polyatomic SO4, 2-. So we'll bring the 2 there, we'll bring the 3 there, so we'll write Al2SO4. Now this number is greater than 1, so I must bracket my sulfate and put 3 outside. Now this is the simplest whole number ratio for this particular compound. This cannot be simplified any further. We can now check to see if it is electrically neutral. So I have aluminum there, 1, and another aluminum ion. And I have 3 sulfate 2- ions. Now here is plus 6 combining with negative 6, which equals 0. So this compound is correct and it is electrically neutral. Ammonium nitrate, NH4 for ammonium ion, and nitrate is NO3-. So bring 1 there and bring another 1 there. You now have NH4NO3. 1 plus cancels 1 minus, so this compound is electrically neutral. Now you can practice by using any of the cations and any of the anions to write any formula that you want to write and check to see if they are electrically neutral. So let's say we wanted to use zinc ion and chloride ion. What would be the formula of zinc chloride? If you said ZnCl2, then you are correct. What about copper 2 sulfite? Then the formula would be CuSO3, because the 2 from the copper, the 2 plus from the copper, would cancel the 2 minus from the sulfite. Hence, the formula would be CuSO3. Lead 2 hydroxide. To do lead 2 hydroxide, the formula would be Pb, bracket the OH and put a 2 as a subscript. So lead 2 hydroxide would be PbOH bracket 2. And if you choose silver nitrate, then the formula would be AgNO3. Let's do this last one. Could you write the formula for potassium oxide? What did you get? Well, if you got K2O, then you are correct. Let's examine some simple covalent compounds and look at their formulas. We are very familiar with simple covalent molecules already because we saw where we wrote simple covalent molecules by working out the number of bonds that must be between each atoms. So let's run through the examples here. Carbon monoxide, 1 carbon atom with 1 oxide or 1 oxygen atom. Now remember that if you're simple covalent, you are not an ion. So it is a carbon atom with an oxygen atom. 1 carbon atom for carbon dioxide with 2 oxygen atoms. For water, it is H2O. So 2 hydrogen with 1 oxygen. Ammonia, 1 nitrogen with 3 hydrogens. Oxygen, 2 oxygen atoms. Nitrogen, 2 nitrogen atoms. And for the halogens, they are diatomics, so they will not exist on their own. So for fluorine, F2, chlorine, Cl2, bromine, Br2, and iodine, I2. I really hope that you will practice writing your formulas for both simple covalent and ionic compounds so that you are able to communicate in chemistry. The language of chemistry is formulas and equations.